Cecilia, everyone's on mute, so I'll chime in if you need me to.
All right. So thanks very much for the introduction. I'm really honored to be here, and I'm very excited to be a part of this conference. So the title of my talk is The Hearts and Minds of Data Science. And my name is Cecilia Aragon, or also pronounced Cecilia Aragon. And I'm going to talk about human-centered data science, which is my field of research. I got my PhD in computer science with a minor in statistics. And I actually worked in industry as a data scientist and software developer for about 15 years before I transitioned into academia. And I'm now a professor at the University of Washington, where I direct the Human-Centered Data Science Lab. And so let's get started. So if we're going to talk about human-centered data science, the first thing we have to do is come up with a definition for what data science is. And I will say here at UW, in the eScience Institute, when we first started talking about data science, we decided we would take a survey of all the stakeholders and come up with a definition we could all agree on. And you can probably guess what happened. The definitions were all mutually exclusive. So, let's take a step back. Back in 2014, there was this buzzword, big data. And, like all buzzwords, it gets overused, but there's a germ of truth in it. There was the problem that we are all overwhelmed with huge amounts of data. And that is really why the field of data science evolved, is how do we handle these vast and growing amount of data? So there were a lot of attempts to define big data, volume, variety, velocity, and nobody could really agree on them. And because this is a talk about human-centered data science, I'm going to give a human-centered definition. Big data is data 2 orders of magnitude greater than you're used to dealing with. That's 100 times as much data as you normally receive. And what that means in practice is that it requires changes in everything that you do. Your work processes, your business processes, all your software has to be rewritten. And this is true pretty much no matter how much, in an absolute value, your data was. So part of my work involved working with astrophysicists and particle physicists. So in the astrophysics group, the Large Synoptic Survey Telescope, which just has had first light, they had to transition from 100 gigabytes to 10 terabytes of data per night. So this again is 100-fold increase. And what they found is none of their software worked, none of their processes for doing their work worked at all. They had to change their social processes, their human processes, as well as their technical processes. And as I said, the particle physicists have for a long time said, we have the biggest data, and it's true. From an absolute scale, the Large Hadron Collider and the particle physicists have to deal with 200 megabytes per data. They went from 200 megabytes of data per second to 20 gigabytes per second. So that's much greater than the astrophysicists had because it's per second instead of per night. But again, it's this factor of 100. And so even though in an absolute sense, they had much more data, it was the same thing. They had to rewrite all their software. They had to redo their social processes. Now, because humans aren't so good sometimes at dealing with understanding what is a terabyte, what is a megabyte, I'm trying to put this in a sense that everybody can understand. So let's suppose your job requires you to read and understand 2 books per week. All right, so you might be, you know, a humanities scholar, or maybe you're a business person who needs to read information. So 2 books per week, that's, you know, many hours, right? But you can do it. It's something that you can manage. Now, what if all of a sudden you have to read 200 books per week? And not only read them, but understand them and glean all the knowledge that's contained in them. Well, obviously, something is going to have to change pretty dramatically, because all the processes you're using now will no longer work. And it's not simply a matter of, you know, rewriting some software. You have to change everything. So that's really what data science is all about, and what really human-centered data science is all about, because data doesn't really make any sense until it's processed by the human brain, until it can be transformed into insights, whether you're in business or science or, you know, the medical field. You need to understand what all that data is telling you. Otherwise, it's meaningless. So let's step back and talk about the rate limiting step in data understanding. This is an old screen, but we all know that the amount of data in the world is increasing exponentially. And so I'm a computer scientist, right? So I know all about Moore's law, which states that processing power in hardware is doubling every 1.5 years. So it's also increasing exponentially. So as a computer scientist, I might say, well, you know, it's okay, we'll keep up. But then, you know, the fact is that we have to transition to the cloud, to parallel processing. And the fact is that not all algorithms are perfectly parallelizable. So Amdahl's law has stated that the effective processing power is not exponential. And so there's this gap. And this is often described as the data science gap. And this is the picture as it's often drawn. But I think there's a really important piece that's missing. And probably a lot of you can guess what that is, since this is a talk about human-centered data science. And that is that human cognitive capacity is not going up exponentially. As a matter of fact, when I first drew this picture, I made human cognitive capacity flat, because I figured, you know, it's not really increasing that much. But I had teenage kids and they told me, oh no, you're wrong, Mom. We are smarter than you. We can do more. So I said, okay, fine. Let's say that there is an increase in human cognitive capacity over time, but certainly it's not exponential. I will concede it might be linear. So with this drawing, we still have gaps, and now there are 2 gaps here. So I want to talk about the normal data science gap is, you know, we need better hardware, we need better software, we need to use parallel computing better, we need to come up with better algorithms, we need to devise better statistical machine learning algorithms. And yes, absolutely, this is that green gap that I've drawn here. We need all those things. I'm not saying we should ignore them. But in addition, there's a gap that's not talked about as much, and that's the gap between human cognitive capacity and what we can process. And that is the regime of human-centered data science. We need to develop better collaborative software and more effective user interfaces. We need to think about visualization, the highest bandwidth channel into the human brain. Visual analytics, which combines visualization with statistical machine learning algorithms. But we also need to think about sociology, about socio-technical systems, about social psychology. How do people interact with data and technology? We need to think about ethics, the ethics of data science, the privacy of what's going on here. We need to think about how our society is affected by the data science we've been doing, and how purely technical data science doesn't always achieve the goals we want. It really involves solving both technical and social issues, and we need to pay attention to both. So for this reason, we need to think about human-centered data science. And to show this to you, I'm going to talk about my own work briefly, with an astrophysics project. This is an older project, but it's still very relevant today because of the human aspects that that were involved. So I contributed I joined the project as a computer scientist and data scientist, and I made 4 contributions to the project. The first 2 were purely technical, and the second 2 were really more social. They really brought into account my knowledge of sociology and social science methods. And the important part is that all 4 were discovered through a human-centered approach that I took, not a standard, you know, give me your requirements document and I'll code it up. And all 4 contributed to the ultimate success of the science. Now, I don't have a lot of time, so I'm just very briefly going to describe the project. Essentially, it involved looking for exploding stars, supernova, by searching a very large number of stars through every night. And so at the time, this was the state of the art. We searched 600,000 potential candidates for supernova, and we had to select only 10 of them. So we needed to have 10 positives out of 600,000. So just again, very briefly, a good subtraction is what you see on the top there, where you subtract one galaxy image from another and you get this perfectly round supernova, potential supernova, which is a star. But there was also a lot of noisy data, bad data. And so you got that C-shaped thing you see on the bottom, which was an error. And when I joined the project, they had no idea that there was a way to deal with this. And I suggested using a Fourier contour descriptor algorithm just by observing them, you know, not by seeing a requirements document. And as a matter of fact, the first thing they did is they heard the word Fourier. They said, oh my gosh, that is too long. We are already at the maximum for our system and we cannot do anything more. So I said, well, you know what? I think I can come up with an efficient algorithm based on what I know about your system. And this again was from my human-centered observations. So I came up with an efficient algorithm that actually ran in constant time. And if you're interested, you can, you know, read the paper. But the important part is that if you go to in the end here, it says that just adding this one algorithm gave us a 41% reduction in false positives with no measurable increase in running time. So that was just 1 out of 4. And if you look at all 4 of the things that I did for this project using this human-centered approach, we gave them a 90% labor savings. So they went from 6 to 8 people working 4 hours a day on grunt labor to 1 person working 1 hour a day. And it could not be completely automated. 2 other groups had tried to completely automate it and had failed. It was the human-centered approach, combining human effort with technology, with the sophisticated algorithms that worked. And what this did is they were free of the grunt labor and they were able to go and write papers, do science, and achieve their goals. So I have just about a minute left, so I'm going to very briefly talk about the work I'm doing now. And so now I'm looking at text data, which is really a vast unexplored resource. It's not sexy like video, but every day we generate more text data than we produced in human history up through 2013. And you know, we're all aware of what this is, so I will skip ahead and say that this text data can be used for tremendous discoveries about our society today, but we really need to be careful. And we need to consider the ethics, privacy, anonymity, manipulation of emotions, a lot of concerns that can occur in this project. And this is a big part of what human-centered data science is all about. And so I'm turning off my timer here. I'm right on time. So if you are interested in more information, I'm happy to connect on Twitter or on LinkedIn. Please do say that you heard me speak at this conference. And also, I and my colleagues we're writing a book called Human-Centered Data Science: An Introduction. It's coming out from MIT Press next year, and it will have much more information about this field. So I'd like to thank you all for listening, and now I guess I should go to the Q&A, right?
Yeah, so thank you, Cecilia. So we have now only about 2 minutes for Q&A, and I think we have a couple of questions out there for you. So thank you so much for the great talk. We're going to transition to Q&A, and for those of you listening, please remember to upvote the questions that you want to have answered.
All right, great. All right, thank you. So the first one is, with a human-centric approach, what is the importance of domain expertise? Okay, so my short answer is yes. Domain expertise is extremely important because most data science now is accomplished in collaborative teams with people with different areas of expertise. And the human-centered approach, of course, is vital because you have to understand social dynamics in these cross-cultural teams. I've actually done a lot of research on how people work together. You know, issues with, you know, people can kind of be prejudiced about other disciplines. And so learning how to respect each other is crucially important. Again, I have a number of papers on this up on my website, and I'm also happy to talk more individually. So that's question one. And the next one is, what resources do you recommend for people interested in human-centered data science? That's a great question. So what I would like to say is, yes, definitely study the traditional data science classes, get good at software development and statistics, but also take classes in sociology. Read science and technology studies. Think about how teams collaborate. Go to conferences that talk about social computing. My own department at the University of Washington, Human-Centered Design and Engineering, is a great place to study the techniques for human-centered data science, because you will learn not just about the technical field, but also about the human-centered approach and why it's important to center the human in this type of work.
Cecilia, this was fantastic. Thank you so much. Oh my goodness, even as the MC, I'm very much enjoying this. So this was great. Thank you so much. So we are actually going to switch over. Next up, we have Smriti.